Chapter 5 begins on page 88. So we're going to be discussing conversions within measurement systems. So for example, like I showed you in chapter 4, how we can convert from one unit to another in the metric system. So we're going to do that for the metric, the household, and the apothecary system. Now, before I get into these systems again, I wanted to make a note of a couple terms that we have this week. So the first one is MEQ. That's the abbreviation for milliequivalents. So keep in mind, these three terms that I'm talking about, they don't necessarily fit into any of the systems that we're discussing. So they don't fit into the metric, household, or the apothecary system. So these milliequivalents is a unit that is going to be used to measure electrolytes. So a really common example that we'll see in the pharmacy would be potassium. So we'll see Kdur or Chlorcon. Chlorcon is probably the most common brand name that you'll see. That's just potassium chloride. 20 milliequivalent is a really common strength. So this is a type of an electrolyte. It's going to be measured in milliequivalents here. Now, international units or just units themselves, don't confuse units here with, any definition of the word unit. Okay, these are going to be specific units that are assigned to drugs, specifically biological drugs. So any drugs that are derived from living organisms here. So an example here, really common, would be insulin. So insulin is going to be measured in units, and those units are going to be specific to that drug. Okay? It doesn't fall into, like I said, the metric, household, or apothecary system. So that was a couple examples there. And then this last term here, specific gravity. If we're ever measuring the specific gravity of something, that actually will not have a unit at the end of it. It's just going to be expressed as a whole number, or just a whole number with a decimal following that. So I just wanted to clarify that, making sure that you know what these words mean, and then also, where they fit into pharmaceuticals. The definitions for those words are actually back on page 73 in chapter 4. Those all should be some of your terms for this week as well. All right, so I am going to be passing out a long table of conversion factors here. And what I mean by a conversion factor is just going to be units that are equivalent to each other that we know, okay? So they're going to be used to find equivalence between two measurements. So all I have done here is just print out the tables. I think most of these are from chapter 6, which we'll get to in a little bit. But we've seen a few of these tables so far in chapter 4. There's also some more in chapter 5. So just some conversions between these different measurement systems here. So for example, 1 cup is equal to 8 ounces. So that is going to be what we consider to be a conversion factor. So for example, 1 cup equals 8 ounces. So a conversion factor is just something that we know. It is given to us. And we can use that to solve for an unknown. So for example, if we were wanting to know how much 5 cups would be, how many ounces is 5 cups? Well, we can use this conversion factor to help us solve for that. And the way that I'm going to show you first how we can do that is by the process known as ratio and proportion. Now, we covered this a little bit in week 1, The steps are here for you to refer back to if you get a little bit lost. I'm just going to go through an example here, and hopefully you will remember this process and you'll start to catch on a little bit. We're going to do a lot of examples here, so by the end of this lecture, you should be pretty confident in how to solve for any problems using ratio and proportion, which is great because we're going to do this, in most of the chapters throughout this book. So let's go back to this problem I have here. So if we know that 1 cup is 8 ounces, we're trying to solve for how many ounces are in 5 cups. So these conversion factors, it's really kind of cool. You can decide to write them as a fraction. So for example, 1 cup over 8 ounces. Now, if we were to take 1 cup and divide that by 8 ounces, our answer would just be 1 because they are equal to each other. So we can either write this as 1 cup over 8 ounces, or we can write this as 8 ounces over 1 cup. Because once again, if we were to take 8 ounces and divide by 1 cup, well, they're equal. So our answer would still just be 1. So these conversion factors that you're always given, anything on these tables here, like 1 gallon is 4 quarts, we could always write them either way. It really doesn't matter which unit you decide to throw on top here, okay? So let's just look over here. So we're going to look at 1 cup over 8 ounces. Now in this ratio and proportion method, we're going to be setting 2 fractions equal to each other. And when you set 2 fractions equal to each other, you have to make sure that your units are equal to each other, either in your numerator or your denominator. So cup needs to be equal to cup, and ounces needs to be equal to ounces. So once we have our conversion factor, which is what we know, we can plug in what we're looking for. Well, this is our unknown. We don't know how many ounces we don't know how many ounces we'll be solving for. So that's going to be what we're looking for. So that can be our x or our unknown variable. But we do know that we're looking for 5 cups. So now we can start to solve for x. So how we solve for x, we're going to use the method of what we call cross multiplication. So we're actually going to look diagonally here, and we're going to take 1 times x, which would just give us 1x. And then we're going to set that equal to our cross multiplication this way. So 5 times 8 gives us 40. Now we want to solve for x. So we need to get x by itself. And I'll get rid of this so we don't get confused with that. So we want x by itself. So right now we have 1 times x. So we need to do the opposite of multiplication, which is division. So we're going to divide by 1 on this side, which will cancel that out. But whatever you do to this side, we have to do over here as well. So divide by 1 on this side. 40 divided by 1 is still just 40. So x equals 40. So we just solved for ounces here. So 5 cups is equal to 40 ounces. Okay, so I have posted this lecture note worksheet in the weekly slides and handouts folder. I'm not going to go through all of these examples, but I'm going to go through the ones that I think are most important. But I would highly recommend you working through these other examples that I don't go through if you're still struggling with how to do ratio and proportion, okay? So I'm going to do several examples on the left side using ratio and proportion, and then I'm going to get into dimensional analysis, and we're going to use the right hand side to do examples of that process. So let's take a look at this first one here. 25 drops is how many teaspoons? Well, we can look at our table to figure out what units we need. And I'm actually going to have you make a correction on this sheet if I have not already done that for you, okay? So I want you all to look at the bottom of this sheet. We see that 20 drops is equal to 1 milliliter. So this is a really important conversion that you will be expected to know, and you're going to need to know that for your certification exam. This has changed a lot over the past years or so. They used to say 15 drops, then they said 18 drops, but now we are using 1 mil equals 20 drops, okay? So if we know this, I want to actually make a correction to the top up here where it says 1 teaspoon equals 60 drops, okay? So the reason why I want to do that is because we just said that 1 milliliter is equal to 20 drops. And then if we look down here, we also see that 1 teaspoon is equal to 5 milliliters. So if we know that 1 mil is 20 drops, then 5 milliliters, we can solve for how many drops that would be by using our ratio and proportion. So if we know that 1 mil is 20 drops, 5 mils, we're going to solve for x here. So 1 times x, because we're cross multiplying. So 1x equals 20 times 5, which is 100. Now we're going to divide by 1 here. Divide by 1. So x actually equals 100 drops, okay? So if we just solved for 5 mils equals 100 drops, then 1 teaspoon must also equal 100 drops. So I want you to make that correction on your handout, like I said, if I have not already. So 1 teaspoon, we're actually going to use 100 drops there, just because it goes along with this conversion that we need to know. Okay, so now we can get into this first question here. So 25 drops equals how many teaspoons? Well, I just said, or we just solved that 1 teaspoon is 100 drops. So we know that. So 1 teaspoon is 100 drops. So now I can set up another ratio and proportion. So if 1 teaspoon equals 100 drops, remember, keep your units equal to each other. I don't know my teaspoon here, so that's going to be my x. And I know I'm solving for 25 drops. So once again, cross multiply. So going this way here, I have 100 times x, which is 100x, equals 1 times 25. So then I need to, this is 100 times x, so I need to do the opposite of multiplication. I need to divide by 100 here. So that will go away. And then I need to divide by 100 here. So x equals 25 divided by 100, which is 0.25. So that is 0.25 teaspoon. Now, if you want to follow the rules here, remember teaspoon needs to be left in fractional units. So going back to week 1, how do we change this into a fraction? Well, we can just read this decimal. So this is in the tenths place, this is in the hundredths place. So this would be 25 hundredths. So if I had 25 hundredths, I can reduce that down by dividing each of these by 25. So divide by 25 here, divide by 25 here, and I'm left with 1/4. So 0.25 is equal to 1/4. So my answer is 1/4 teaspoon. All right, I'm going to look at this example here. 0.6 kilograms equals how many milligrams? So we can do this a couple different ways. We can either look at these conversion charts and we can see, 1 kilogram is 1,000 grams, 1 gram is 1,000 milligrams. So we could use these conversion factors, or we can go back and use that number line that I showed you earlier in the chapter 4 lecture here, which I think this is going to be the easiest way anytime you're converting in the metric system to just use this number line. So if we're going from kilograms to milligrams, we need to look and see how many decimal places we're moving. So 1, 2, 3, 4, 5, 6. We're going 6 places to the right. So if my decimal is here, I'm going to go 6 places to the right. So 1, 2, 3, 4, 5, 6. And then I'm going to fill in my zeros. So 1, 2, 3, 4. We have 5 zeros there. So 6 kilograms is actually equal to, oh, I put my decimal in the wrong spot there. I apologize. It's actually 6,000 milligrams. All right, now I'm going to do an example from the apothecary system here. So first we need to figure out what this is saying here. So if I look at this unit, I can see from my table that that is the symbol for drams. And then the number is going to follow the symbol. So this is 5, 6, 7 here. So I have 7 drams. And then this unit is ounces. So I'm looking for how many ounces. So now let's take a look at our conversion chart here. So we see 1 fluid ounce is equal to 8 drams, 8 fluid drams. So we can see that that's the same case for fluid ounces and then regular ounces as well. So if we're looking at volume, that's when we're going to use fluid ounces. If we're looking at weight, that's when we're going to use our regular ounces here. So either way, 1 ounce is equal to 8 drams. And if it helps you, by all means, write that out in English. So 1 ounce equals 8 drams. So that's our conversion factor. Now we can set up our ratio and proportion. So 1 ounce over 8 drams, because that's what we know. And we're going to set that equal to, we know we want ounces on top, drams on bottom. We're solving for 7 drams, and we're trying to figure out how many ounces that would be. So solving for x, we're going to cross multiply. 8 times x would just give us 8x equals 1 times 7, which would just be 7. Now we're going to divide. So divide this by 8 and divide this by 8. So x, we really don't even need to change this into a decimal because the apothecary system prefers us to use fractions. So x is actually 7/8. So 7 drams equals 7/8 of an ounce. All right, now I'm going to go into the process of dimensional analysis. So this is just another way that we can solve for these problems, just a little bit different here. So in dimensional analysis, we're actually going to be multiplying fractions rather than setting them equal to each other. So step one, always identify the unit of the answer needed. So start with what you're looking for. Start with the unit that you're solving for and follow it with an equal sign, okay? So let's just take a look at an example here. We'll look at the right side of this lecture notes page here. So 0.175 milligrams equals how many micrograms? Well, if you look at your chart, you can see that 1 milligram equals 1,000 micrograms. Now, usually with metric units, I like to use that number line, but let me just show you this example here with dimensional analysis. So step one, once again, it says start with the unit that you're looking for and follow it with an equal sign. So in this case, we're looking for micrograms. So we're going to start with microgram and follow it with an equal sign. Now, step two says set up a fraction so that the unit of the desired answer is in the numerator of the first fraction. Okay, this unit will never be canceled. So what that means, set up a fraction that has this unit that you're looking for on top or in the numerator. So we're never going to cancel that unit because that is what we're solving for. Now it says set up the next fraction so that the unit of its numerator is the same as the unit of the denominator of the first fraction. Okay, so first of all, we need to take a look and see, well, I want micrograms on top. The only thing I know about micrograms so far is that there's 1,000 micrograms in 1 milligram. So that, once again, is my conversion factor. So I'm going to use that. So I know that there are 1,000 micrograms in 1 milligram. Now with dimensional analysis, once again, we're going to be multiplying fractions, not setting them equal to each other. So that third rule just said, set up the second fraction so that the numerator up here matches the denominator of the first fraction. So since I had milligrams down here, I'm going to put milligrams now in the numerator of the second fraction. So this is different than ratio and proportion, okay? Remember, in ratio and proportion, our units were equal, okay? Now that we're multiplying, the reason why we want these units diagonal is so that they can cancel out. Because if I had milligrams over milligrams, those units would cancel. So now I've already used my conversion factor, so I don't need to use that again. So let's see what we know about milligrams. Well, I know that I have 0.175 milligrams. I'm solving for micrograms, so I'm solving for this unit on top. This here is by itself. It's just standing alone by itself. So if it helps you remember, we just want to keep this by itself. We can always just put that over 1 because any number divided by 1 is still itself here, okay? So now these milligrams, these units, are going to cancel out. And we're going to be left with the unit that we're looking for, which is micrograms. So now we can just solve this here. So we have 1,000 times 0.175. So remember, when we're multiplying fractions, we're just going to multiply our numerators, multiply our denominators. So you can use your calculator if it helps you, or if you just look at your decimal points here, we're doing 1,000, so we have 3 zeros there, so we're going to be moving 3 places. So 1,000 times 0.175 gives us 175. And then 1 times 1 is just 1. So remember, any number over 1 is still just that number. So this actually equals 175. Running out of room to put my unit on there, but that is micrograms. Now, I know that's probably a little bit confusing if that's the first time you're seeing dimensional analysis. That's why I'm going to go through a couple more examples here, okay? So that was one with the metric system. Let's do this one here with the household system. Either one here. Let's do this one here. We're going to go from pounds into ounces. So if you're not sure how many ounces are in a pound, you can look at your conversion chart here. So let's see what we have. We have household to metric. Household, 1 pound equals 16 ounces. So we know that. So 1 pound equals 16 ounces. Now let's use dimensional analysis, okay? So we're starting with the unit that we're solving for, and we're following that up with an equal sign. Then our first fraction needs to have that unit in the numerator, and we're never going to cancel that unit out. Now we can plug in what we know. We know that 16 ounces is equal to 1 pound. Then we're going to multiply that by a fraction that has this unit in the numerator. So we want pounds up here. We've already used our conversion factor. So now we're going to use what we know. We have 1.2 pounds, which is just by itself. So we can put that over 1. My pounds are going to cancel out since they are diagonal from each other. I'm going to be left with ounces here, so that's what I want. So now I can solve. So 16 times 1.2 gives me 19.2. 1 times 1 is just 1. So I have 19.2 ounces. 19.2 ounces. All right, let's do one more here. We'll do this. Let's do both of these actually, so I can show you an example when you have more than one conversion factor. Okay, so let's use the apothecary system here. Here we have ounces, and that is IX. So remember, if a smaller number comes before a larger, we need to subtract. So 10 minus 1 is 9. So this is actually 9 ounces equals how many grams? So like we looked at earlier, we know that 1 ounce is 8 grams. So that's what we can use for our conversion factor. So for dimensional analysis, start with the unit that you want. So we're going to start with grams, follow it with an equal sign, and keep that unit on top. So we know that 8 grams is equal to 1 ounce. Follow that with a multiplication sign, and then a fraction that has this bottom unit on the top. So we've already used our conversion factor. Now we know that we're solving for how many grams are in 9 ounces. So that 9 is what we want here. That's by itself over here. So we can just put that over 1. My ounces will cancel out, and now I can solve. So 8 times 9 gives us 72. 1 times 1 is just 1. So we're left with 72 drams. So 72 is more than 10, and it's not 20 or 30. So we can just leave that in Arabic numbers. So just regular 72 there. Okay, now this last example. 120 drops is how many tablespoons? Well, if I look at my chart here, I see that 1 teaspoon is equal to 100 drops, and 1 tablespoon is equal to 3 teaspoons. So 1 teaspoon is equal to 100 drops, and 1 tablespoon is equal to 3 teaspoons. So you can see neither one of these are a straight conversion from drops to tablespoon, but that's okay because if I have 2 conversion factors, I can still use dimensional analysis, okay? So that's why dimensional analysis is a great method to learn and understand because we cannot use ratio and proportion if we have more than 1 conversion factor like we do here, okay? So dimensional analysis, set it up just as we have before. Start with what we're looking for. We're looking for a tablespoon. Follow that with an equal sign and a fraction that has that in the numerator. So now, what do I know here? The only thing I know is that 1 tablespoon is equal to 3 teaspoons. So 1 tablespoon is equal to 3 teaspoons. So I've used that one now. Now we're going to follow this with a multiplication sign and then a fraction that has this denominator up here in the numerator. So now, once again, what do I know about teaspoon? Well, I know that 1 teaspoon is equal to 100 drops. So now I've used that second conversion factor. Now, if we look and see here, my teaspoons are going to cancel. But right now, I'm left with tablespoons over drops, okay? I just want to be left with tablespoon. So I have to cancel out this drop. Well, how we do that is just like we did before. We get a new fraction where the numerator is equal to this first denominator here. So drops down here, drops need to go back up here. What is left? Well, my 120 drops. That is by itself over here, so we can just put that over 1. Now my drops can cancel, and I will be left with tablespoon, which is just what I'm looking for here. So once you get that unit that you need and it's by itself, now we can solve. So here we have 1 times 1 times 120 gives me 120. And then I have, oops, sorry there. Now we have 3 times 100 times 1 gives me 300. So 120 divided by 300 gives me 0.4. Now this is household, so we should leave that in a fraction form. So if we read that number, that would give us 4/10, which if we reduce that down equals 2/5. So 120 drops equals 2/5 of a tablespoon. All right, this last example here, I just want to do one more example with this number line, this metric system number line. So we have 1.25 grams equals how many milligrams? Well, we're starting at our base unit, which is gram, and we're going to milligram. So we're going 1, 2, 3 places to the right. So that's how many places we're going to move our decimal. So I have 1.25. We're going 1, 2, 3 places to the right. So add my 0 there. 1.25 grams is equal to 1,250 milligrams. So just as a review, the steps for ratio and proportion and some examples are in your slides. So same with dimensional analysis, steps are there. Another example. Also, the concept I just went through for going, using that number line to convert between units of the metric system. So make sure you're reading through these slides as well. If you're still struggling with any of these concepts, please come in on your workday and I will be more than happy to go over some additional examples with these, with each of you or in a group setting, either one.